Well, hello again, my wonderful math students. Welcome to another fabulous lesson with your favorite math teacher, me, right? Okay, well, so today's goal is to use the Pythagorean theorem to confirm right, acute, and obtuse triangles. Woo! Before we go on, I thought I'd let you watch this little demonstration of optical illusion for another few seconds. Crazy, isn't it? Whoa! All right. Well, let's do a little review before we get there. In case you forget what they are, acute triangles are triangles where all three angles are less than 90 degrees, as you can see there. A right triangle, of course, is one is a 90-degree angle, and an obtuse is one of the angles is larger than 90 degrees. So, hope you enjoy some of my animations in this lesson. Some of them are a little bit crazy. All right, so visually, when you're looking at acute or obtuse, you can see that the acute triangle is kind of cute. All of its little angles are going to look smaller than 90 degrees. All right, you're going to see it's going to look, you can just tell. I mean, you can see it on most of them. Obtuse, on the other hand, one of them is going to look larger. It's not going to be straight up. It's not going to be all three smaller. All right, one of them is going to look larger. So visually, you can see it. No tricks there. So visually, what kind of triangle is this one? Okay, so visually, this looks like a right angle, right? A right triangle, visually. But it could be a trick. It could be a trick. So what we're going to do is we're going to review, as you know, Pythagorean theorem only works on right triangles. That was something that we pointed out quite a bit. So it looks to me like, well, we can see 8, 6, and 10. This would be what we would call the hypotenuse if this is a right triangle. If it is, we don't know. I'm just going to do that little thingy there, and I'm going to put a big question mark. We don't know. Okay, so I'm going to set up our equation. A squared plus B squared equals C squared, and we'll use, I don't know, we'll just do it like this. 8 is the A squared, and 6 is our B squared, and does it equal C squared? Whoops, C squared, which is 10 squared. All right, does it equal that? 8 squared is 64. 6 squared is 36. And 10 squared is 100. So, if you add together 64 and 36, do we get 100? I think so. We do, don't we? So it is equal. That was supposed to be a question mark there, too. We weren't sure. But it is equal. 100 equals 100. So this is indeed a right triangle. So we tested it. Let's do another one. This one looks pretty good too. I mean, the picture looks like a right triangle. This is obviously going to be C, and we'll make this one A and this one B. So A squared, which is 10 squared, plus B squared, which is 9 squared. Does it equal, that's an equal sign. Does it equal C squared, which is 11 squared? So what is 10 squared? 10 squared is 100. 9 squared, what is it? 81. And 11 squared, get out those calculators. 121. Do you see where this is going already, people? I'm looking at this, I already know, right? 100 plus 181 is 181. That does not equal 121. So no, this is not a right triangle. Not a right triangle at all. Whew, okay. So now you know how to test it. Now it's your turn to tell me, is this a right triangle or not? Okay, so what happens when one of the sides is made shorter? The hypotenuse, for instance. What happens if we do that? So here's a right triangle, 12, 20, 16. 12 and 16 we've kept, and we've made the 17 shorter. What happens? How are we going to make this, or what kind of a triangle are we going to end up if all three sides actually touch? Well, that's what we're going to do. We're going to bring in that 12, right? we're going to bring it in. So we're going to, just fold it over. And I didn't have an animation for that, sorry guys. But we're just going to fold it over to make it touch. So now if the longest side is too short to make it a right triangle, what kind of triangle does that make it? That has to be done in either an acute or an obtuse triangle. So what do you think? That's going to be acute, right? Because all three angles now are smaller than 90 because you took only the biggest angle and you made it smaller. Whoa. All right, let's take a look at what happens. Start with the same triangle, but what happens if we make the longest side longer than that? What happens to our 12? It's not going to go in, is it? It's going to go out. And what happens when we go out? We have to make it bigger. That angle there becomes bigger. Where's my pen? I'm trying to get my pen so I can point to it with you guys. Oh, goodness gracious. Where'd it go? I have no mouse. Wait, I have a mouse when it's down here. There it is. So you can see this angle here has gotten bigger. So this makes it an obtuse triangle. So we just realized, what did we just mean? We can use the Pythagorean theorem to figure out what kind of a triangle we have. If we end up with c squared, if it equals a squared plus b squared, we know we have a right triangle. We've known that for a week or two now. But if c squared ends up bigger than a squared plus c squared, or b squared, we've got an obtuse triangle. And if it ends up smaller, we've got an acute triangle. So here's a really nice little chart to show you what I'm talking about. So if it's equal, if c squared is equal to these two added together, it's a right triangle. If it's smaller, remember the pointy side to the small is pointing at the smaller. The bigger side is the bigger. This c squared, if the biggest side is smaller than those two squared added together, then it's an acute triangle. And if c squared is bigger than them, it's an obtuse triangle. Okay, so let's see how to do that again. We are going to just figure this out. No drawing, okay? We're going to plug these things in. So we've got a squared, which is 8. So it's 8 squared plus b squared, which is 12. So it's 12 squared. Does that equal, or what do we get there if it's 16 squared? So we've got 8 squared, which is 64, plus 12 squared, which is 144. And I'm going to just put a box here from now on, all right? We don't know what it is. It's going to be either an equal sign, a less than, or a greater sign. So 16 squared is not one of the ones I've got memorized. Whoa, that is not right. Clear your calculator, Mrs. Horn, before you go doing crazy stuff. All right, so it equals, 16 squared equals 256. Okay, so what is 64 plus 144? 64 plus 144. I get, did you do it on your calculator? I get 208. Whoops, 208. Let me write that again. 208. And I've got 2, 5, 6. So when we draw our less than greater than sign, we need to draw it with the bigger side pointing toward the bigger number. 208 is smaller than 256. Let's look up here at our little chart. If c squared is smaller, then it's an acute triangle, and A is our answer. If I went too fast for you, rewind, watch that again. It's your turn to figure one out. Okay, so there's a review. This is our little chart. This is what we need to remember, and it's very logical. One more time. See if you can do it without the chart. Classify it. Okay, so look at this one and take a look at that little diagram there. What's going to happen with that side, that 12? Are we going to go make it an acute triangle, or are we going to go up and make it an obtuse triangle? You figure it out. Last question, all yours. You can do this. Come on. All right, our summary. We just learned how to use the Pythagorean theorem to classify triangles, not just going by their looks, because we don't always trust the pictures. Can't always trust them. And boy, those obtuse triangles, they get to be really sad sometimes. Silly. All right. Thank you for watching. Have a great day.